In this video, we're going to see how we can perform two-sample tests for difference in means when we have independent samples. And for this, we're going to use data file purchase order. So in this video, we're going to see how we can perform two-sample tests for difference in means of two population groups. So imagine we have two groups of people, two population groups, for example, female students versus male students. Students in Cal State system versus students in university or UC system, CSU system, UC system, right? And we want to see if the difference between the population mean of these two groups is actually equal, less than or equal, or greater than or equal to a specific number as our null hypothesis. And of course, the opposite of the statement null hypothesis would be an alternative hypothesis, right? So the idea is that we should take random samples from each population and then get the sample statistic from each one of them. The basically, in this case, sample mean. And then using these two sample statistics or sample means, we can find a test statistic, the value of test statistic, and then we can find the p-value, and then the rest of the hypothesis testing procedures, basically. When we have independent samples, as I just described in this example, when we're comparing, let's say, male student versus female students, if we're comparing, for example, GPA of male students versus female students, in this case, we have to take the samples that we're going to take are going to be completely independent. There's no way you can find one person that belongs to both samples. So there is no commonality actually between these two samples, and because of that, we call these independent. So when we have independent samples, completely different samples, we can use either of the three tests. These are the tests that Excel provides. Two-sample test, actually either Z-test, two-sample for means, or T-test, two-sample assuming unequal variances, or T-test, two-sample assuming equal variances. And each one of them has a different set of assumptions. The first one, when we know the value of the variance, population variance for both populations. The second one, when we do not know the value of population variance and we cannot assume that they are equal. The third one, we don't know the population variance for both population, but we can assume that they're equal. As you can see, the least restrictive one, the least restrictive test would be the T-test, two-sample assuming unequal variances. This is less restrictive. Here, we have a very strong assumption knowing the exact value of variance, population variance. Here again, we have another strong, even though we relax this one, we assume that the variance of population is not known, but still we have a very strong assumption, equality of variances. This one itself has a test that we will talk about it later. But the less restrictive, as I said, would be when you run the assuming two-sample, assuming unequal variances for the difference in means. And that would be a case of T-test. So we're going to use this tool here in Excel for this example, for purchase orders. So we have a data file purchase orders. In this data file, we have a few data and a few information fields regarding multiple suppliers. In this specific example that we're going to do, we are comparing two suppliers, the lead time of two suppliers, and we want to see if the lead time of one of them, aluminum sheeting, is significantly longer than the lead time of durable product. If that is the case, we can drop aluminum sheeting as, from our supplier list, basically. And then, so alpha would be 5%, so we want to run this test. So I'm copying this and I'm gonna go to my Excel file, purchase orders. So here I have the data file and I'm gonna copy the question that I have in Excel. So as you can see, we want to compare two suppliers, aluminum sheeting. We have the list of suppliers. What I'm gonna do now, we don't have the lead time. We're comparing these suppliers based on lead time. We don't have the lead time actually specifically and clearly defined in this data file. So we have to first find it. So what is the lead time? Lead time is the time that it takes for an order to be received. From the day that you put the order, that you release the order or place the order until you get it. The item is arrived, the item is delivered and you get it. So the difference between arrival date and order date, that would be actually the number of days that it takes for you to receive the item. So the lead time would be the date, arrival date minus order date. That will give you the number of days that it takes from the order dates to the arrival date for each one of these orders. Each row in this table would be one order. So you have like order numbers, item numbers, you know exactly from which supplier is coming from, and so on. So if I just do that, so this is what I'm trying to find. And all right. So now we have the lead time for each order. Now, what I'm gonna do, this data file is not sorted, so I have to sort this. So I'm gonna filter this table and I'm gonna sort it based on the supplier name, A to Z. And as you can see now, it's now much clearer. So I'm gonna maybe change the color, change the field for aluminum sheeting to maybe green, and for durable product to another color, maybe blue. That just helps us to distinguish it. And when we're putting it in Excel, when we're putting it in the tool, the TTest tool, that would be easier to actually separate it. So, so now I have the lead time, and I have a few other fields that I'm not really interested in right now. So I'm just gonna hide some of these. You may want to continue without hiding these cells, but that just gives us more space. So I'm going to hide these cells. Now we have the supplier, and then we have the lead time. So this is similar to having, actually this is exactly what we're doing. We have a sample of past orders from each one of these two suppliers, and we know the lead time. So the numbers that I have here would actually make each one of these numbers, each one of these sets make up a sample from each one of these suppliers. So now, so we have our samples ready. So in order to solve this problem, I'm gonna first write down the null and alternative hypothesis. So they said that, let me just make this a little. All right. Purchasing managers have noted that they order many of the same types of items from these two suppliers and are considering dropping alum sheeting from its supplier base if its lead time. So I'm going to consider alum sheeting as my first supplier. So lead time mu, which would be the population average of the lead time for alum sheeting. If its lead time is significantly longer than mu, durable product. So mu of, or the population mean of the lead time for the first supplier, alum sheeting, and then the second is durable product. Now we just need to determine the size, the sign, sorry. So the difference is 0. We are testing to see which one of these two values, these two population parameters, are, which one of these two is bigger. So the difference therefore would be 0. That's the benchmark difference that we're looking for. So now our job would be to determine the size. We would drop the first supplier if its lead time is significantly longer. So if the distance, so that would actually look like, that would look like a claim to me. So if the average lead time for alum sheeting is significantly bigger than the same thing, the lead time for the lead time of durable product, then we would drop alum sheeting. So this would sound like a claim. This would sound like something that we would need strong evidence for. So this statement, I put it in my alternative hypothesis. And then the opposite, including equality, goes to null hypothesis. So this is basically the development of the null and alternative. Level of significance is given to us is 5%. 5%. All right. So now, in order to get the value of the test statistic and the p-value, we're going to use TTest, TwoSample Test for mean, assuming unequal variances. So this is the type of test that we're going to use. This test, we can find it in data tab, data analysis, data tab, data analysis. and just type T and then look for this. T-test to sample assuming unequal variances. This is the type of test that we're using. And like I said, we use this when we have independent samples. This is our sample 1 and then sample 2. As you can see, they have different numbers of orders in them. The orders that we're getting are, um, they're completely different. They're coming from different suppliers. So, and then we can't really pair each one of these with one at the other sample, right? So we can't really pair them. We can't find any dependency. We may be able, but that takes too much effort, too much time. So for this one, we're gonna use TwoSample, assuming these are independent and assuming the variance of lead time for these two is not equal. They're not equal. So I'm taking assuming unequal variances. For this one, we need to put the variable 1 range. Variable 1 range would be the first sample, whatever the first population, whatever we called it. If it was two-tailed, it doesn't matter which one you put first. But this is obviously an upper tail type of test. Upper tail type of test, right? So the sign is greater than, strictly greater. So it would be an upper tail type of test. And because it's a one tail type of test, it's extremely important to use to actually be careful actually when you're selecting the population group. So alum sheeting, this is my sample, the first variable. The second one is durable product. So sample 1, sample 2. Sample 1 is coming from supplier 1. Sample 2, orders, lead times of orders coming from supplier 2. Hypothesized mean difference would be 0. This is this number that I'm talking about. So you just put 0. Alpha is 5%. We just determined that. It's given to us. There's no label. The numbers that I put here, there is no text. They're all pure numerical values. So I don't need to check this one. If you check this one, the first values are going to be excluded. They're going to be treated as labels, as text. But you shouldn't do that. And then just put the output in the same data file. So I'm gonna make sure that I have the right name for the variables. And then, so this is the lead time for the first supplier. And then durable products. All right. At the end of the day, so we have the mean average lead time for alum sheeting, the first supplier, and then the average mean, sample mean for the, I have the sample mean for both suppliers coming from both samples. And as you can see here, there is a significant difference when we see it, but in order to make sure that the difference is significant, is actually significant, statistically significant, we need to take a look at the test statistic and the p-values. So it's not enough just looking at the sample means. All right, so we see the difference, but let's see if the difference is significant. At the end of the day, so here you have list of numbers, but what matters the most is going to be the p-value. So this test actually makes our life easier because it provides us with the p-values. So this tool provides us with two p-values, p-value one tail and two tail, right? But if you remember before, we had p-value lower tail, upper tail, and two tail. So the two tail is fine. For this one, we know that this one is an upper tail type of test. Again, how do we determine what type of test we're dealing with? We just look at the sign at the alternative. So this is strictly greater than, so it would be upper tail type of test. And here now our job would be to determine if this is an upper tail, p-value upper tail, or p-value lower tail. So for this one, just go back to here to our PowerPoint. It says we just need to take a look at the test statistic. If test statistic is negative, the one tail p-value is the lower tail p-value. If the test statistic is positive or zero, then the p-value is the upper tail p-value. So I'm just gonna come back, take a look at the test statistic. It's positive. Therefore, the p-value that we have for one tail would be looking at the right side of the distribution. So p-value, if test statistic is positive, the p-value is a small number. This number has to be less than a half for sure. If test statistic is zero, this would be a half. This would be, yes, 0.5. And then doesn't matter really which left and right will be the same. Both of them will be 0.5. But anyway, if the test statistic is positive, since test stat or t stat, t is positive, p-value one tail shows p-value upper tail. Upper tail. So how do we get p-value lower tail? P-value lower tail will be 1 minus p-value upper tail. So if we were looking for p-value lower tail, that would be equal to 1 minus p-value upper tail. We just realized this is p-value lower, p-value upper tail because the test statistic is positive. So for finding the p-value lower, we don't need it. It's our test is upper tail, so we just need to look at this number. But anyways, if we want it, this is how we find it. 1 minus p-value, 1 minus p-value upper tail would give us p-value lower tail. But anyway, this is an upper tail type of test, so we just need to look at the p-value upper tail. So since, and then p-value upper tail is obviously less than alpha, so we can go ahead and reject the null hypothesis and take the alternative hypothesis. So we're gonna reject this and take the alternative, which means that there is actually a significant difference between the lead time of these two suppliers. So so I'm just gonna write it down. Since p-value in this case p-value upper tail is less than alpha, and alpha is 5%. Is less than alpha, we can reject. We reject the null hypothesis and conclude with 95% confidence that that the average lead time, that the mean lead time for aluminum sheeting supplier is significantly, or is statistically, so we have enough evidence to say that it's significantly greater than the lead time, the mean lead time for durable products. Since p-value upper tail is less than alpha, we can reject the null hypothesis and conclude with 95% confidence that the mean lead time for aluminum sheeting is statistically greater than the mean lead time for durable product, which in business terms means this means we can drop. We now have enough evidence, even though this, the sample sizes are not that big. So our statistical test is suggesting that we can drop aluminum sheeting, but if you're really doing the business with these suppliers, you may want to really consider a larger sample. You may want to consider other important factors before you make such an important decision. All right, so this is the conclusion. And this is how we perform t-test two-sample, assuming unequal variances for when we're dealing with independent samples, and when we are testing for the difference between population mean of two population groups.